Hey physics students, Mr. Zentis, and I'm talking about power today. I'm on page 179, we're still in chapter 5, and power is the rate at which work is done. The units are watts, and those are joules per second. Now we're going to frequently refer to horsepower. Horsepower is 750 watts. And that's all a horsepower is. Let's see if I could illustrate what power is. If we have a mountain, this is my mountain, and let's say we have a cable car that this cable car is pulled up the mountain directly, and here's our end point. Then we also have a bike, and the bike must meander in order to go up this steep mountain. Both the cable car and the bike have the same displacement. They both have the exact same displacement. So both the cable car and the bike do the same amount of work. Now, the car does it in less time. The cable car. Therefore, more power. Alright, so you could think of it this way. Time and power are inversely related. They're inversely related. So, if we go back to our units, as time goes down, power goes up. As power goes up, time goes down. Those two are inversely related because of the way they are in the equation. People have power ratings too. So if we took an example, let's say we have a flight of stairs, we have a displacement, and we'll use some numbers this time. We have a displacement of 20, and we have our person here who is vigorously climbing these stairs. This person is, let's say, 80 kilograms, and it does this in, we need a time of 1.8 seconds. Alright, so power equals work over time, because joules are work. Then let's just get a force here, because we need force for work. Force equals mass times acceleration. So 80 kilograms times 9.81 meters per second squared. We'll need that, because that's going to be our work. Because it's work, if you recall, is force times distance. So work equals force times distance. So here's our force. We just got that from the mass of the person. and our distance is 2 meters, isn't it? Alright, so we have our work. This is work. And now all we need to do is set it against time. And the time is, so all this is work, we could say. And then down here we just need time. And so the power is 871 watts, I said, are the units for power. So 1 horsepower equals 750 watts. So this person is doing about 1.2 horsepower. Notice that we have meters per second here. Meters per second should sound very, very familiar to you. Meters per second equals velocity. So really, you can think of power is newtons times meters per second. And so really, power is force times, power is really just force times velocity. That's all power is. Now, we know this intuitively. If we say that a machine or a person is powerful, if something is very powerful, we say it's strong and fast. And that makes sense because that's exactly what our equation says. Power is force times velocity. So velocity is the speed, force is the strength. And so something that's powerful is strong and fast. That makes sense to us. So if we let's try to practice. Pardon me. Let's try to practice one. 2 students. One lifts 100 pounds. Lifts 100 pounds 10 times in 1 minute. Student 2 lifts 100 pounds 10 times in 10 seconds. Which does more work? Which does more power? We wouldn't say does have more power, which has more power, huh? Well, they both do the same amount of work, but certainly because we have less time, student 2 does more power because there's an inverse relationship between time and power. As time goes down, power goes up. So you should see that they both lift the same amount of distance, so they're both doing the same amount of work, but person 2 does it in less time, so they have more power. Let's try one in your book, page 181. This is a section review question. Number 2, look for a fairly simple one to start. We have a person, and apparently this person is being lifted. We have a distance of 5. So this is number 2, the section review. A motor-driven winch pulls a 50 kilogram. Okay, so this is a 50 kilogram person, 5 meters. That's our distance. With a constant speed of 1.25 meters per second, and so we want to know the power. And we should also be able to tell work. Alright? Well, in this situation, we know power because we know force. Force equals 50 kilograms times 9.81 meters per second squared, and that's going to be 490.5 newtons. So 490.5 newtons times 1.25, which is our rate, which is our meters per second, that's going to give us the power, and power is 613 watts. Alright, because power is just force times velocity, and we've been given velocity as meters per second, so that's simple enough. Here's our meters per second. Work is just newtons times, so all we need for that is newtons times the distance. So force times distance is work. We have our force already, 490 newtons, and we know our distance is 5 meters. So if we multiply that, work equals 2.45 times 10 to the third